Vistam 151, go around.
Go around, Vistam 151.
Vistam 151, heavy, thanks. The last departure lost the wheel on departure, so we're going to have to shut the runway down. So fly runway heading and maintain 3000.
Roger, Vistam 151.
Omnicon 7 heavy, we're going to have to...
Welcome to Brasher Warning, the podcast that dives deep into aviation incidents with sharp analysis, insightful discussions, and just a touch of edge. If you're passionate about aviation and love a good post-incident breakdown, you're in the right place. Before we take off, be sure to subscribe, leave a review, and share with your crew. Let's get into it.
All right, so we're diving into the crash of United Airlines Flight 266.
A Boeing 727.
Yeah, that went down back in 69.
And 1969.
And we've got a pretty hefty NTSB report to guide us through this. It's going to be a fascinating journey.
It will be a somber one, though.
Definitely, as we try to understand, what happened and why.
What makes this crash so compelling is that it really highlights the critical importance of redundancy in aviation.
Okay, redundancy is key.
It is.
Got it.
We often take that for granted today.
So let's set the stage for this.
Okay.
Flight 266 was en route from LAX to Milwaukee.
With a stopover in Denver on the way.
Right, and the weather in LA that night was...
less than ideal.
Yeah, it was nighttime light rain fog, low cloud cover.
Not exactly a pilot's dream.
No, not at all.
And to add to that challenge, they knew before they even took off that their number 3 generator was inoperative.
Wait a second. They took off knowing that a crucial piece of equipment was down?
It wasn't completely unheard of back then. The minimum equipment list actually allowed for it.
Okay, so they were allowed to, but
with caveats.
What were they?
It meant that they had to be incredibly meticulous about managing the electrical load on the remaining generators.
Oh, so like if you're running your house on one single power outlet, you can't have everything turned on at once or you're going to overload the system.
That's a great analogy.
Okay, so they take off with this generator issue, and then what happens?
Shortly after takeoff, the fire warning bell for the number 1 engine goes off.
Oh, man. Can you imagine the tension in the cockpit?
Absolutely.
At that moment?
You've got that bell going off.
And so what did they do?
They followed their standard procedure, they shut down the engine, and they requested to return to LAX.
Okay, and that was the last communication
That was it.
anyone had with Flight 266.
The last anyone heard from them.
Okay, so fire warning engine shut down, and then silence. This is where it gets really unsettling. Did they actually have an engine fire?
Well, that's where the NTSB report gets really interesting, because their investigation suggests that the fire warning was likely a false alarm, or at most an overheat.
So not an actual fire.
It seems that way.
So they shut down a perfectly good engine based on what might have been a faulty warning.
Yeah, and that decision, understandable given the circumstances, had a cascading effect. Shutting down that number 1 engine put immense strain on the already compromised electrical system.
Right, because they were already operating with one generator down.
Exactly, and that ultimately led to a complete electrical power failure.
Oh, man. I can see where this is heading, and it's not good.
No, it's not. Imagine this. You're flying at night in bad weather, and suddenly every instrument in the cockpit goes dark.
Whoa.
Your attitude indicator, your compass, your radios, everything.
Oh, my God.
That's the reality the crew suddenly faced.
So their last line of defense, that standby electrical system, that kick in?
It either malfunctioned or wasn't activated properly.
So they were essentially flying blind in the dark with no instruments.
That's exactly right.
All right.
And without that attitude indicator, the instrument that tells pilots if they're level climbing or descending, they became spatially disoriented.
They lost their bearings.
They did. The aircraft entered a high-speed, steep angle descent and ultimately crashed into the Pacific Ocean.
That's just horrifying.
It is a terrible tragedy.
So a likely false alarm triggered this domino effect of failures and culminating in this tragedy. So what did the NTSB conclude about why the number 2 generator and the standby system failed? Was there a specific mechanical fault they could point to?
Unfortunately, no. They couldn't pinpoint the exact reasons for those failures, but the report does highlight this critical issue present in aircraft electrical systems back then, where lack of robust redundancy.
So you're saying if one system failed, there wasn't a reliable backup to prevent a total loss of power.
Exactly. And we have to remember this was 1969. Cockpit automation was in its infancy compared to what we have today.
So pilots back then had to rely much more on their skills and judgment. And in a situation like this one on Flight 266, I imagine the NTSB also looked into whether the crew's actions played a role in that generator failure.
Of course they did.
Especially their management of the electrical load after that fire warning.
It's a crucial part of any accident investigation, trying to understand that human factor. However, the evidence was inconclusive.
So we may never know for sure whether their actions directly contributed to the failure.
That's right. Makes you think, doesn't it?
It does.
This accident really shows how a chain of events, each seemingly manageable on its own, can converge to create this truly disastrous outcome.
Absolutely. It also makes me appreciate how far aviation safety has come since then.
Oh, for sure.
But let's not get ahead of ourselves.
Right.
We were talking about the NTSB investigation and their findings. I'm assuming they didn't just stop at identifying the causes. Did they offer any recommendations to prevent this kind of tragedy from happening again?
Absolutely. The NTSB's recommendations after Flight 266 were a turning point in aviation safety. They really pushed the industry to adopt a more proactive, systemic approach.
So let's break down those recommendations. What were some of the key takeaways?
Well, one of the most significant focuses was, you guessed it, redundancy in critical systems.
Right.
Remember how Flight 266 lost all electrical power because there wasn't a reliable backup?
Right.
The NTSB came down hard on that, strongly recommending automatic switching to standby power in the event of total generator failure.
So basically, if the main power goes out, a backup system should just kick in automatically. No more fumbling for switches in a darkened cockpit.
That's right. The goal was to create a fail-safe mechanism to prevent a complete loss of power, like what happened on Flight 266.
Makes sense. What about the attitude indicator? That seemed to play a major role in the crew's disorientation.
Right.
Did the NTSB address that as well?
They did. They recommended the development of more robust attitude indicators that wouldn't be solely reliant on electrical power. Imagine systems that could provide some level of attitude reference, even if the main electrical system goes kaput.
So backup instruments that could help pilots maintain control, even in a total electrical failure.
Precisely.
Wow.
It was a huge step forward in aviation safety thinking. They were essentially saying, okay, we need to assume that failures can and will happen. How do we design systems that can gracefully handle those failures and keep the plane flying?
That's incredible. And I'm guessing improved pilot training was also high on their list of recommendations?
Absolutely. The NTSB emphasized the need for training programs that could equip crews with the skills and knowledge to handle complete electrical failures. They understood that even with better technology, pilots needed to be prepared to face these kinds of extreme situations.
Right. You can have the most advanced backup systems in the world, but if the pilots in the cockpit don't know how to use them effectively...
It's all for nothing.
Yeah, exactly.
The human factor is always going to be critical in aviation safety. It's this complex interplay of technology training and human judgment.
It's fascinating how the NTSB took this multi-pronged approach, tackling both the technological and human aspects of safety. They weren't looking for a Band-Aid solution.
No, they weren't.
They were trying to create a more resilient system overall.
That's right. That's a key takeaway here. The NTSB wasn't just focused on preventing a repeat of the exact same scenario. They were trying to anticipate other potential failures and build in safeguards to protect against them.
So in a way, they were trying to get ahead of the curve.
Yes.
To make sure the industry was prepared for future challenges we might not even be able to foresee today.
Exactly. And that forward-thinking approach has had a lasting impact on aviation safety. The changes they recommended have undoubtedly saved countless lives in the decades since.
It's remarkable to consider the ripple effects of this one tragic event.
Yeah.
But as I think about all this, I can't help but wonder about something.
What's that?
We've been delving deep into the technical and procedural aspects of the crash. You know, the nuts and bolts of what went wrong. But what about the emotional side of things? What must it have been like for those pilots realizing they were in this dire situation, hurtling towards the ocean with no control over the aircraft?
Yeah, that's a perspective that often gets lost in the technical analysis of these events.
It does.
We can dissect the mechanical failures, retrace the chain of events, but we can never truly fathom the terror and helplessness those pilots must have felt in those final moments.
And the passengers, too. They were plunged into darkness, completely unaware of what was happening, with no way to brace themselves for what was to come.
Absolutely. It's heartbreaking to think about.
It is.
And it reminds us that behind every accident investigation, behind every dry technical report, there are human lives lost, families shattered, and a profound sense of loss that can't be captured in data points and diagrams.
It really adds another layer of gravity to the NTSB's work. They're not just dealing with systems and procedures.
No.
They're grappling with the aftermath of human tragedy.
They are.
And their responsibility to find answers and make recommendations to prevent future tragedies is immense.
Absolutely. Their dedication to uncovering the truth, to learning from these mistakes, is a testament to the victims of these accidents and a beacon of hope for a safer future in aviation.
Well said. Okay. We've covered the probable cause of the crash, the NTSB's key findings, and those crucial safety recommendations. But I think there's one more piece of the puzzle to examine.
I think I know where you're going with this.
The human factor. We talked about how the NTSB couldn't definitively say whether the crew's actions contributed to the generator failure, but their report does raise some intriguing questions about the role human judgment played in this tragedy.
Yeah, it's a complex issue, no doubt. And this crash happening back in 1969 really brings to light how much cockpit design and pilot training have evolved over the years.
So paint me a picture. What were cockpits like back then? How did they compare to the sophisticated flight decks we see today?
Well, think about the level of automation we take for granted nowadays. Autopilot's advanced flight management systems, warnings and alerts that are much clearer and more specific. None of that was really available to the crew of Flight 266.
So pilots back then had to rely much more on manual control and their own judgment.
Yes.
Especially during emergency.
Exactly. Their workload in a situation like the one on Flight 266 would have been immense. Managing the electrical system, troubleshooting that fire warning, navigating in those awful weather conditions, all while trying to maintain control of the aircraft.
You've been incredibly demanding.
It would have.
And if I recall correctly, the NTSB report mentioned that the crew might have been distracted by the fire warning, potentially impacting their ability to manage the electrical load effectively.
Yes, that's a crucial point. They were operating under extreme pressure, and it's certainly possible that their focus was pulled in multiple directions, leading to critical oversights.
Which brings us back to the importance of training. Pilots today undergo extensive training in simulators that can replicate all sorts of emergency scenarios, including total electrical failure.
Absolutely. Simulators allow pilots to practice procedures, develop muscle memory, and hone their decision-making skills under pressure. That kind of training was far less developed back in 1969.
So while we can't say with certainty whether the crew's actions directly caused the generator failure on Flight 266, it's clear that the technology and training available to them were not what we have today.
That's right. And that highlights how aviation safety is and always will be a constantly evolving field. We learn from these tragic accidents, refine procedures, develop new technologies, all with the goal of making flying safer.
It's both sobering and inspiring, really. Accidents like Flight 266 are stark reminders of the fragility of complex systems, but they also serve as powerful catalysts for improvement.
Well said. And it's a testament to the dedication of everyone in the aviation industry who works tirelessly to minimize risks and prevent future tragedies. Every new safety measure, every enhanced training program is a tribute to those we've lost and a commitment to a safer future for air travel.
So as we wrap up this deep dive into the crash of United Airlines Flight 266, what are the key takeaways you hope our listener will remember?
Well, first and foremost, the critical importance of redundancy in aviation. Having backup systems for critical functions is not just a good idea, it's absolutely essential.
Right.
It's what prevents a single point of failure from leading to catastrophic consequences. Secondly, the human factor is always at play.
Always.
No matter how advanced our technology becomes, human judgment, decision-making and training will always be crucial components of aviation safety.
Yeah.
And finally, aviation safety is an ongoing journey. We must never become complacent, always striving to learn from past mistakes and push for continuous improvement.
It's a poignant reminder that while we've come a long way since 1969, the pursuit of safer skies is an enduring mission. And that's the legacy of Flight 266, a tragedy that forced us to confront our vulnerabilities, and in doing so made air travel safer for everyone.
Thanks for tuning in to Brasher Warning. If you enjoyed this episode, make sure to subscribe so you never miss a flight with us. We'd love to hear your thoughts. Drop a comment or review, and don't forget to share the podcast with your fellow aviation enthusiasts. Until next time, stay sharp, stay safe, and keep soaring.
American 1552, contact center 127.0.
1552, we're going to be Mayday, Mayday, Mayday. We have an engine failure. We're going to return to DFW.
1552, roger. And which runway do you need?
We'll take 18 right.
Roger, make 1552, turn right, heading 020, just going to maintain 8,000.